Hello everyone, and welcome back. In this tutorial, I'll be showing you how to prepare a 3D model for printing using FlashPrint 5. We will be using the model we exported from Tinkercad in our last video. We'll be preparing it for printing on the Flashforge Adventurer 5M. By the end of this tutorial, you'll understand how to import your model, check the printer and material settings, slice the model, preview the toolpath, and prepare the file for printing. Once FlashPrint 5 is open, the first thing to confirm is that the correct printer is selected. At the bottom left corner of the screen, we can see that the selected printer is the Adventurer 5M, using a 0.4mm nozzle in normal mode. This is important because the printer profile determines the build volume, nozzle size, slicing limits, and default print settings. Before importing your model, always make sure the selected printer matches the machine you intend to print with. Next, we'll import the STL file. To do this, click the Add Model icon and locate the STL file on your computer. Once selected, FlashPrint loads the model directly onto the build plate. You should now see the model appear inside the printer's virtual build area. This virtual build area represents the physical print bed of the Adventurer 5M, so any model we want to print must fit within this space. After importing the model, take a moment to inspect its position and orientation. The model should be sitting flat on the build plate and should not be floating, tilted, or placed outside the printable area. In this case, the model appears as a flat rectangular design with raised text and a raised logo detail. Once the model is positioned correctly, the next step is slicing. Click Start Slicing at the top of the screen. This opens the slicing settings window where we can choose nozzle size, material type, and slice profile. We have already set the machine type to Adventurer 5M. The nozzle size is set to 0.4mm, which is the standard nozzle size for many FDM 3D prints. The material type is set to Flashforge PLA. For this tutorial, we'll be using basic mode in the slice settings. The visible settings include layer height 0.2mm, fill density 15%, print speed 300 mm per second, shell count 2. A 0.2mm layer height is a good general purpose setting. It gives a reasonable balance between print quality and print time. The 15% infill density means the inside of the print will not be completely solid. Instead, FlashPrint will create an internal structure to support the part while saving material. The shell count controls the number of outer walls. A shell count of 2 is suitable for many basic prints. These default settings are a good place to start, especially when printing with PLA. Before slicing, always confirm that the material selected in the slicer matches the actual filament loaded into the printer. In this tutorial, the material selected is PLA. If you are using another material, such as PETG or ABS, you should select the correct material profile because each material uses different temperature and cooling settings. Using the wrong material setting can affect bed adhesion, surface finish, strength, and overall print success. After confirming the settings, click Slice. FlashPrint will now process the STL model and convert it into a printable toolpath. This process turns the 3D model into instructions that the printer can understand. The output is no longer just a 3D object. It becomes a set of movement paths, extrusion commands, temperatures, and layer-by-layer instructions for the Adventurer 5M. Once slicing is complete, the Slice Preview option becomes available at the top of the screen. The preview shows how the model will be built layer by layer. On the right side of the preview, FlashPrint displays the estimated print time and material usage. For this model, the estimated print time is about 33 minutes, and the estimated material usage is about 22.06 grams, or approximately 7.4 meters of filament. These estimates are useful when planning prints, especially if you are preparing multiple models or managing filament usage in a classroom or workshop. On the left side, we can see the color legend showing different print structures such as solid fill, outer shell, inner shell, travel moves, retraction, brim or raft if used, supports if required. This is very useful because it allows us to check what the printer will actually do before we start printing. For this model, we can see the large flat base, the raised logo, and the engraved text. The slicer has generated paths around the edges and details of the design. At the bottom of the screen, we can use the Layer Preview slider to inspect the model layer by layer. This allows us to see how the print starts from the bottom and gradually builds upward. For flat models with raised details, this is a helpful way to confirm that the text, logo, and surface details have been sliced correctly. If something looks wrong in the preview, it is better to go back and correct it before sending the file to the printer. Never skip the preview stage, especially when printing a model for the first time. After checking the preview, we can send the file directly to the printer. Click the Send to Printer option. FlashPrint opens the connection window and scans for available machines on the network. For this to work, your computer and the Adventurer 5M need to be connected to the same network. Once the printer appears, select it and send the G-code file. In the multi-machine control window, we can see the connected printer, its IP address, temperature readings, and print status. The file is then sent to the printer, and the printer begins preparing for the job. Another option is to save the sliced file. Click the Save or Download icon, then choose where to save the file on your computer. FlashPrint saves the sliced file in a format that the Flashforge printer can read. In this video, the file is being saved with the same name as the original model. Saving the file is useful if you want to transfer it manually to the printer or keep a copy for future use. Thank you for watching, and in the next tutorial, we'll continue exploring more features that can help you prepare better 3D prints.